Alright everyone, so in this video I'm coming at you guys with a couple of nomenclature in organic chemistry, and I'm probably going to turn this into a multiple part series. I'm not sure yet, and with each part what I wanted to do is kind of with each part just make them more difficult as it goes. And for this first part I mainly wanted to cover organic 1 nomenclature and as well as some alkenes. I'm actually not sure if from my personal experience when I took organic chemistry 1, I didn't cover alkenes until organic chemistry 2. So I'm not sure if it how it works with other institutions, but I do have some alkenes on here. But yeah, I mainly wanted to cover the organic nomenclature that you would have to, or compounds that you would see in organic chemistry 1. So if you want to, you could go ahead, pause the video, try them out, and we'll go over them together. Okay, so let's just get started with our first compound right here. As always with naming organic compounds, we want to start with the largest carbon chain. So here, our largest carbon chain in this case, we would start from the left side. So here we have 1, 2, 3, 4, 5, 6, 7, 8. And this would be our largest carbon chain. Our carbon chain has 8 carbons. And we want to start from the left side because if we start naming from the right side, we get a number of 23. If we were to add up the numbers for our substituents and what carbons they're connected to, we would get a number of 23. Whereas if we start from the left, we get a number of 21. So we always want the lowest possible number. And here at this point, we want to start identifying our different substituents. So I'm going to label this in red. So here we can see we have 1, 2, 3 different methyl groups. So I'm just gonna write methyl. And then here on the 4th position we have 1 ethyl group. So ethyl. And in our 5th position we have a tert-butyl group. So T-E-R-T, butyl. Okay. So now that we identified all our substituents, we can start actually naming this compound. So when we name it, we want to start with the first substituent alphabetically. So in this case, prefixes don't count. So for this tert part, we don't count it. So instead, our first letter is going to be the B in this case. So we're going to start with the tert-butyl when we name this compound. So we're going to have 5 because it's in the 5th position. Then we're going to include the tert-butyl. So T-E-R-T, butyl. All right. And our next compound would be our ethyl group. So our ethyl group in this case is in the 4th position. So we're going to write 4 ethyl. And now we do our methyl groups, but in this case here we have 3 different methyl groups. So we're gonna write down 2, 3, 7. And now instead of just plugging in the name for our methyl, instead of just plugging in the word methyl onto our name, we gotta include the prefix. So in this case it's gonna be tri to indicate those 3 different methyl groups. Then we can start writing methyl. And now because our longest carbon chain has 8 different carbons in it, we start including the word octane. Okay. So for this problem, this would be our final solution for this compound. I'm gonna go ahead and erase it though because this name is kind of big. So now we move on to our compound number 2. Here it's kind of the same thing. We identify our carbon chain or our longest carbon chain. And this one is kind of obvious. So 1, 2, 3, 4, 5, 6, 7. And again, we want to identify the different substituents. So I'm not going to write them down, but as we can see here, we have 2 methyl groups as well as an ethyl group. So, and actually, let me see, 4, 8, that's 13. Actually, we don't want to start off from the left side. We're going to start from the right side. because it looks like we get a lower number if we were to start from the right side. 5, 6, 7. Okay. So now what we want to do is, I'm not going to write down the different substituents, but we have an ethyl and 2 methyl groups. And of course, alphabetically, ethyl comes first. So 3 ethyl. And now we have 2 methyl groups in our 4th position. So we're going to have 4, 4. We include the prefix. In this case, for 2, it's going to be di. Then dimethyl. And because our longest carbon chain has 7 carbons in it, we're going to include heptane. Now this would be our solution for compound number 2. All right. Now we move on to compound number 3. Here we have a singular propyl group as well as a cyclopropyl group. Cyclopropyl group. And now when we name this compound, again, we want to identify the longest carbon chain, but in this case, it's just our ring. So we're just going to number our substituents around that ring. And there's 2 ways we could go about this. We could start numbering from here to here, so we have 1 and 2. Or we could start numbering starting from here, 1 to 2. You always want to put priority towards the one that comes first alphabetically. And because this one is cyclopropyl, we want to put this one as first priority. So we're gonna put 1, 2, and I'm just gonna number the rest, even though you don't have to really. Okay, so now we start naming this one. So here, this one comes first alphabetically, so we have 1 cyclopropyl. And then next we have our 2 propyl. And because it's a ring, we're going to write cyclohexane. So Actually, I'm not sure if this is getting the full name. Hopefully it does. I'm just going to write down the rest in the bottom. So I'm just going to make sure like it's that. Okay. So this would be our solution for our compound number 3. 1 cyclopropyl, 2 propyl cyclohexane. That's a mouthful. Okay, so that was compound number 3. We then move on to compound number 4. And this one, it's kind of even more obvious what our longest carbon chain is going to be. But we first want to make sure we start at the right side. So it looks like if we were to start from the left side, we get the lowest number. 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so now we identify our different substituents. This one is kind of simple. We have 1 ethyl group here and 1 methyl group. So what we're gonna do is now when we start naming it, we go by alphabetical order again. So here our ethyl comes first. It's in the 9th position. So we have 9 ethyl. Then we go to our methyl group, which is a 3 at the 3rd position. 3 methyl. And because our longest carbon chain has 12 carbons in it, I believe the prefix, let me just make sure. The prefix for number 12, even though, okay. So the prefix for 12 carbons would be dodecane. Even though in most classes you're probably not going to go as far, you're probably not going to go any further than 9 carbons. This would be the prefix if you were to have 12 carbons in this case. This would be your final answer for compound number 4. All right. Now that we have that, now we have compound number 5. And again, we want to identify the longest carbon chain. So if we were to base it off the ring, here we have 4 carbons, but in this chain we have 5 carbons. So when we name this molecule, we mainly are gonna go along this path right here. But now it just comes to numbering the different carbons. So we're gonna go 1, 2, 3, 4, 5. Whereas this one, the longest carbon chain was the ring. In this one, our longest carbon chain is just this alkane right here. All right. So again, we go by alphabetical order. Here we have this would be a cyclobutyl group, and this one would be just a methyl group. So cyclo comes first, so we have 3 cyclobutyl, and here we have 1 methyl group, and at the second position 2 methyl. And because we have 5 carbons in our longest chain, we're gonna have pentane. And this would be your final answer for compound number 5. 3 cyclobutyl, 2 methyl pentane. All right. And here for number 6, here we're looking at it in a Newman projection. So this is almost, first what we're gonna do is write out the compound and see what it looks like. So that way we don't have to deal with this 3-dimensional mess pretty much. So I'm gonna write down the molecule in red. So here we could see the 2 carbons in the front are just connected to, they're connected to 2 hydrogens. So I'm just gonna write down the 2 carbons right here. And we could see that they're both connected to a CH3, or it runs along here, then it's connected to a methyl group. Then we have the 2 back carbons. You can't see them from here, but they're behind these 2 carbons right here. So what we're gonna do is write out a line just like that. I'm just gonna write down dots to indicate the different carbons. And then here we could see that, or actually this right carbon right here has a bromine attached to it. So I'm gonna write Br. I'm actually gonna make sure that this is also getting this, all right. But we could also see that they're connected as well, just like that. So this is what our molecule looks like from a different perspective, pretty much. We're not looking at it from a Newman projection type thing. And now we just name it just like normal. So again, we want to go alphabetically, or we could start from 1, 2, 3 or 1, 2, 3, but we want to give the numbering priority to the one that comes first alphabetically, which in this case, it's going to be our bromine. So we're going to have 1, 2, 3. And now, yeah, we just name it at this point. So here we have 1 bromo, and then we have 3 methyl. And because it's a ring, a 6 carbon ring, we're gonna have methyl cyclohexane. Hexane. So this would be our final solution for number 6. 1 bromo, 3 methyl cyclohexane. Gonna go ahead and erase this. Okay, so now we go to our alkenes. And now for alkenes, we again want to look for the longest carbon chain, but the longest carbon chain has to contain our double bond in it. And we mainly want to put our numbering priorities towards the double bond. So when we number this compound, we're going to start from here and go along this path. Oh, that's a 3. So we have 1, 2, 3, 4, 5, 6. Here, as we can see, our double bond is going to start with a 2. So as you'll see in a bit, we're going to include this 2 to indicate where the double bond begins, pretty much. So the rest of pretty much everything before the alkene part, when we name it, is pretty much the same thing. So here we have 2 different methyl group, or not methyl, but 2 different ethyl groups. So we have 3, 4. We want to include the prefix, so diethyl. And now, because it's because our longest chain has 6 carbons, we have the prefix hex. But then we want to include the number in which our double bond starts at. So we have hex 2E. So this would be our solution for compound number 7. 3,4-diethyl hex 2E. All right. Same idea here for number 8. However, this one is kind of a bit different because now we want to indicate kind of not really the rotation, but we're going to use what is called RNS configuration to name this molecule. So when we number this molecule, we want to start where our double bonds have the lowest number when we add them up. So what we're going to do is start here, 1, 2, 3, 4, 5, 6, 7, and 8. Here we don't have any substituents connected to this molecule, but we do have a bunch of double bonds. So what we can do is just write down, actually first what we're going to do is label RNS to these different double bonds. Here we can see for our third carbon, we would have, I'm sorry, not RNS. What am I talking about? It's going to be E and Z. Yeah. I said RNS, that's my bad. That's for single bonds. We're going to use E and Z for double bonds. So in this case, our second double bond at the third position, that one is going to have E configuration because they are on opposite sides, as you can see here. And then for our third double bond, which is in the fifth position, they're on the same side. So we're going to have 5Z. So we're going to include that at the start. Actually, I don't know why I'm writing it like that. My mistake. I'm going to write it. So 3E, then we have 5Z. Okay, so we're going to include that at the start of our compound naming. And notice how for this first bond, we don't have to include E or Z configuration because here we have 2 hydrogens attached and you can't put priority on 2 different hydrogens. So for this first double bond, we can't use E and Z configuration. So we're just going to leave it off like that. So we have 3E, 5Z. Then because our longest chain in this case has 8 carbons, we're going to have octo. Then we look at where our double bonds start. So we have 1, 3, and 5. 1, 3, 5. And then we include the prefix. So because we have 3 double bonds, we're going to have tri. Then we can write out our ene. So this would be the name for our molecule number 8. If you weren't using EZ configuration, then you could go ahead and just throw this out, and you would just have octo 1, 3, 5 triene. Sorry. Okay, so on to our last compound right here. This one, it doesn't matter where we start off. Either way, it's going to be the same thing. So I'm going to start off from the left side. 1, 2, 3, 4, 5. And now when we do our naming part, we want to name the substituents first. So here we have 2 methyl groups sticking out of the third position. So we have 3. We would have 3,3 dimethyl. All right, and now we have 2 different double bonds. So actually it's going to be 3,3 dimethyl. Then our longest carbon chain has 5 carbons, so we're going to have pent as our prefix. And now to indicate where the double bonds are at, they're at 1 and 4. 1, 4, and now we include the prefix for the ene part. So here we have 3,3-dimethyl pent 1,4-diene. So this would be our final answer for molecule number 9. And so yeah, this, again, I plan to try to make more parts for this. Probably as I go on, do harder molecules. But for now, I wanted to just start off with kind of like the basics, as well as some alkenes that we could go over. And so yeah, hopefully this video helped you guys out in some organic chemistry nomenclature. If it did, please go ahead and subscribe, leave a like or comment. And yeah, I'll see you guys later.